This is a lovely, very short section. Pressure. Pressure is defined as it was in physics as force per unit area, and we normally use a barometer to enable us to measure pressure. At one point, mercury was very convenient, but as you know, mercury has come out of favor. We're going to use it here, though, as we talk about this section. If we have mercury, it would be 760 millimeters. I'll talk about that in a moment. If instead of mercury we would use water, we would need to have a barometer that was 30 feet high. Not convenient for indoor use nor outdoor use under different seasons, all right? Many of you are going to have a question. Where did this equation come from? Density times height for one material equals density times height for another material. Know that the derivation is in this problem, and you are doing homework 10.18 where you actually use it. Before I go to the next slide, again, I like to bring in real life examples. When someone's measuring your blood pressure, they are measuring your systolic, which is your maximum, over your diastolic, which is your minimum. And notice here it is measured in this picture in milliliters. So what do we have here? Well, in chemistry, we talk about a standard atmospheric pressure. It will support a column of mercury, there it is, that is 760 millimeters high at 0 degrees centigrade and at sea level. Here is the conversion factors that you will use. You will be converting between millimeters of mercury, atmospheres, and torrs. So when I first started teaching this, I really wanted to know, why was this height 760 millimeters? So I went digging, and what I learned is that when people use closed-end tubes of different heights, what they found is the mercury would just rise to a certain level. Those larger tubes, it would stop at that point, and for the tubes under 760, it would fill it. Well, that was enough to convince me, and I hope it's enough to convince you. All right? We're going to just do a very easy conversion here. We're going to say what pressure in atmospheres corresponds to 220 millimeters of mercury. So you know how I've been pushing dimension analysis since the first day we met. Well, that's all that this is. We know that one atmosphere is 760 millimeters of mercury, and that comes out to 0.2897. So here you can see this is a sloppy way to put down a number. I didn't indicate the number of sig figs. What if I had put a little decimal point? It would say that this has 3 sig figs, and this would come out to be 0.290 ATM. That is why you always want to use decimal points, so that you do have this. Now, another question you're going to have is, how do I work with this? And what I would do if we were in class is I would draw these 3 things on the blackboard. I would put up these 3 YouTubes, and no, these are not internet videos. I know that's a very bad joke. But what I would do is I would say, if I have a YouTube and it has liquid in it, and I have gas 1 and I have gas 2, if I see an equal level, I would say that the pressure of 1 equals the pressure of 2. But what if instead I had something that looks like this? Here's gas 1, here's gas 2. What I would say is the pressure of 1 is greater than the pressure of 2 because it's pushing down on that end of the U-tube. And then I would also draw it in the opposite direction, where I would have the left-hand side higher. That would be gas 1. This is gas 2. And here I would say the pressure of gas 2 is greater than the pressure of gas 1. So then you are presented with this picture in your text, often on a quiz, if I can load it into Carmen, and I will say, what is the pressure of the gas? Well, the pressure of the gas, by definition, is the pressure of the atmosphere plus the pressure of the height of the mercury. Since I am pushing down, what I am seeing here is the pressure of the gas is greater than the pressure of the atmosphere. That will force me to make a correction on my gas calculation. And again, I am going to leave that to you because you learn more when you do it yourself. And realize, think about how these 3 different options can work.